Hello and welcome to the Circle Trig story problems video. We're going to have a lot of trig story problems throughout the term, but this one is specifically about circle trig, or you'll be using circles. So as I go through each of these, I am going to draw a picture, I am going to show my math, and then for problems 2, 3, and 4, I'm going to write a sentence. I'm not going to write a sentence for number 1 because it's not necessarily a story problem. But first I want to share with you the math that I'm going to be using. So all of these problems are talking about arc length, or sector length is another way that you can think of it. And it's not going to be of the whole circle, it's going to be of part of the circle. So if I want to find a part or a percentage of a circle, I'm going to do my, part over my whole times my total circumference. This is what I'm going to be using, whether I'm given radians or degrees. Just doing part over the whole is going to say, hey, I want this fraction or this amount of the circumference. So like for like a really quick example, you know, if you have a pizza and you're, going to eat, one of the slices out of 8, your part would be 1 slice out of the 8, and you're going to multiply that to the total circumference of the pizza. Or you can think of it like the pizza crust. So that might be, 6 pi or something. So that's kind of how we'd be looking at that. So if we took a look at problem 1, it says find the arc length between 2 points on a circle. Oop, it doesn't say the angle, with a central angle of 35 degrees and a radius of 10. So if we were to draw a picture for this, so here's my circle. Here's my center. Okay, we're going to say that's about 35 degrees. So that's kind of like the amount of the pizza that we're having. And this is going to be a 10-meter pizza radius, maybe more like 10 inches for the pizza analogy, but what have you. So when I take a look at this, I go, okay, well, my total circumference, just a reminder, circumference is 2 times pi times your radius. So in our case, it's going to be 2 times pi times 10, or 20 pi. But I don't want all the way around the circle. I just want this part right here. I just want that fraction. So if I think about, well, what is that fraction? Well, let's see, we're dealing in degrees. So my fraction is going to be 35 degrees out of 360. So that's my part over my whole, and I want to know that amount of my total circumference, or 20 pi. So again, this is part over the whole times my circumference. And when I do that, that's going to get me about 6.11 meters. So not too bad. So that's the math that we're going to be using for these story problems. But now we have to put them a little bit more into context. So let's take a look at problem number 2. So let's see, Charleston, West Virginia is due north of Jacksonville, Florida. Find the distance between Charleston, so it's giving us the degrees north of the equator, and Jacksonville, giving us the degrees north of the equator. And we're going to assume that the radius of the Earth is 3,960 miles. So let's start by drawing a picture. Oh, I did not leave myself a ton of space. Okay, so let's see. If we were to draw a picture, that's my very oblong Earth. Let's see. We're going to say this right here is the equator. That's the line that cuts it in half. And we're going to say, okay, if this is the center, I'm going to say that Jacksonville is right here. And we know that Charleston is due north, so it's going to be above it. About right here. And we know that the radius of the Earth is 3,960 miles. And then for the picture, okay, we know Jacksonville right here, that's 30.33 degrees. We know from the equator to Charleston is 38.35 degrees. So what we want to know is if we're looking at that distance between Charleston and Jacksonville, we want this sliver right here. That's what we're going to be looking for. So in order to do that, I'm going to say, okay, so Let's take the degrees of Charleston. Let's subtract the degrees of Jacksonville, and it's going to leave us with what's left. So in this case, it's going to be 38.35 minus 30.33, leaving us with, 8.02 degrees. So that kind of blue shaded in area right now is 8.02 degrees, and that's the distance between them. Next, let's find our circumference. So C is equal to 2 times pi times our radius, which is 3,960. Or we get that is going to be 7,920 pi. So from here, again, my part over my whole, or in this case, since we're looking for just this sliver right here, I'm going to look for this part of that angle, which is going to be 8.02 over 360, or like we said, part over the whole. And we're going to multiply that by 7,920 pi, also known as the circumference. And that's going to give us 554.3 miles. Since this does have context to it, but like unlike our previous problem, we're going to write a sentence. So we can just say that Jacksonville and Charleston are 554.3 miles apart. And there you have it. So we're really finding that part over the whole, but what if we are looking for something more than just the part? What if the part is more than the whole? What do I mean by that? Let's take a look at problem number 3. So problem number 3 says you were riding your bike along a road and your tire goes over a nail. The nail makes 5 full rotations and an extra 90 degrees before the tire pops. Okay, so let's think about how we would draw this. I'm going to give myself an axis, kind of over here, off to the side. And I have to think, okay, so when the tire picks up the nail, normally we start over here, but no one's sitting there with like a nail gun, like trying to shoot at your tire. It's going to pick it off the ground. So we're going to start down here. And we're going to go around 1, 2, 3, 4, 5 rotations and an extra 90 degrees. So this is kind of showing how far the nail has moved around. It's gone around 5 full rotations and then an extra 90 degrees, which for us is just a quarter of our circle. So how far did the nail travel before the tire popped if the radius is 2 feet? Okay, so first let's find the circumference of our circle. So for us, it's going to be 2 times pi times a radius of 2, or circumference is 4 pi. So you can start with part over the whole, but first I think about this and I go, okay, we're going 5 full rotations. We're going around the tire 5 full times, or we're doing 5 of the circumference. So I'm going to do 4 pi times 5 to give us 20 pi, or in this case, that's going to be our circumference times a full rotation, or how many full rotations that we have. But that's not going to give us our fraction. So if we want our fraction, we're going to do 4 pi, times 90 over 360. So this time I did circumference first. It's fine either way. So you'll have your circumference times part over the whole. We know that 90 degrees is 1/4 of our circle, but this is kind of how we get that fraction. But if we do that, that's going to give us just pi. So if we do 20 pi plus pi, or our just trying to find the total rotation, that's going to give us 21 pi. So if you want to leave your answer like this as 21 pi, I'm okay with that. Feel free to also plug that into your calculator, and you'll get 65.97 feet. So if I'm to write a sentence, I might say, the nail traveled 21 pi feet, which may not mean anything to us. So if you write 65.97 feet, that works for me too. So we're still using the circumference times part over the whole, but this one just had a little bit extra to it, right? So we really have to think in the context of the story, what does this mean? Problem number 4 kind of builds off of this, and we'll go over a problem similar to this in the Go formative that I think you'll find interesting, but it's really all about the radius. So like I said, this story problem starts the same. You're riding your bike along a road, your tire goes over a nail, nail makes 5 full rotations and an extra 90 degrees before the tire pops. When the tire pops, the nail falls to the ground. How far did the nail fall when the tire popped? Okay, so let's think about this. We have to think about where is the nail when the tire pops. And you can use this previous diagram as well, but I'm just going to draw a new one for the sake of our story. So kind of drawing my chart right here, we know we're going to say that this is the ground. This is where the nail was picked up. And we know it went around 5 times. I don't really care about that. I just care about where it ends up. And we know that it ended up over here, 90 degree, with that extra 90 degree rotation. And we know that the radius is 2 feet. So if you think about, well, how far does it have to fall? It's going to fall the total amount of our radius, which in this case is 2 feet, and then any extra height we may have. So if we end up somewhere up here, we're going to have an extra height out of our 2 feet. But for us, when I think about my height here, or my y value, this point is 0, right? It doesn't have any extra height. So we're going to add the extra height of 0 feet, just giving us 2 feet. So for this example, we can say the nail fell 2 feet after the tire popped. Now you may think it's silly that I just added 0 feet because it's like, that doesn't mean anything. But when we get into our Go formatives tomorrow, we will be adding something other than 0. So let me know if you have any questions. Otherwise, I look forward to seeing you tomorrow.